Thank you so much. Welcome to Selective class. This is physics lesson, grade 12. Physics, we're talking about moments of a force, and these are objective of the lesson. Before we give objective of the lesson, we have rules of the class. So class, you are welcome to physics class. How are you all? Fine. Thank you. Before we start the lesson, I'm going to make rules and regulations during the class. Rule number 1. If you want to answer a question, you put up your hand. Is that clear to everybody?
Yes.
If you want to go out, put up and ask permission. Is that clear to everybody?
Yes.
You are not concerned if you have a concern or want to ask a question, put up your hand. I'll come to you, tell me your question, your problem. Is that clear to everybody? Is that in the favor of the house?
Yes.
Thank you so much. We have our rule. Now, objective of the lesson, we are going to look at, by the end of the lesson, we will be able to define what is moment of a force. 2, we shall demonstrate an activity to verify principle of a moment. And 3rd, we shall solve problems on moments of a force. Now, our previous lesson, we talked about equilibrium of a force. Equilibrium. And we learned that equilibrium means when forces act on an object and they appear to be, they are at rest. We have stable equilibrium, we have unstable equilibrium and neutral equilibrium. Today, we are going to look at moment of a force which shall implement all those activities. Now, who amongst you can tell me any activity in the house, any object you know, when you apply a force to it turns. The object has turning points. Anybody have an idea? Yes, David? Hello. Yes, steering, car steering, good. Good, car steering, yes. Seesaw, good. Very good example. Another example there. This is seesaw. Somebody is here, another person is here. This is a turning effect. So if their weight balances, it moves up and down, up and down. So the turning effect is here. Any other person? Any other person? Yes, can think of any object? Yes. Yeah, bicycle, paddling. Yes. For example, if this is a bicycle, and our man is here paddling. This is a paddle. As you paddle it, as you apply forces, the bike moves by virtue of the chain, isn't it? So this plane serves as a turning effects of the force of the bike. Now we listed this example. So what is moment of a force? Moment of a force defined as turning effect of a force. The turning effect produced by a force turn as what? Moment. Look at principle of moment. We use seesaw as an example. If 2 persons is sitting here, and this is the turning effect. If the weights of object A and object B, if they balance, if the total resultant force here, assume resultant force here is 100 newtons, another 100 newtons is here. Obviously, this object will be at equilibrium. But if the weight of this person is 50 newtons and this place is 100, does it balance? No. So what happened? This force will outweigh it. the total force here will be heavier than this force. So the principle of moment says that for object to be at equilibrium, the clockwise moment should be equal to what? Anti-clockwise moment, in short. So let's put it into writing to find the center of gravity of that object and see where will the balance point be. Everybody, let's start with remove the only this one. See where will the balance point be. Remove the where the balance point be. Where's the balance point? Has it balanced? Yes. Good. Good. So this means that the resultant force at the right side equalizes the force at the left side. Yes, it balanced. Good. Group 3, good. Group 4, good. Yes, it balanced. Very, very good. Yes. Stage is in equilibrium. Now let's try to look at the question involved and we shall solve it. Imagine you are having a meter rule. What here? And a weight of 50 grams is attached to the end. Half meter rule, 50 grams. From this to the left edge is 20. The distance from another end to this place is also 30. So how do we find the weight attached here for it to balance? We know the principle of moment is that on the board from principle of moment, we know that clockwise moments should equal to anti-clockwise moment from what we just demonstrated right now. So from this example on the board, we want to find the mass that will attach here to balance this meter rule. We know that the force and the distance equal to the force and distance here. So with this, 50 grams times 20 centimeters will give us 5 times 2 give us what? 10, 2 zeros. Is that it? So equal to what? 30s. S will give us what? What's the final answer? Yes, what's the final answer? 33. 3. So gram. So we know that if 33.33 is here, this meter rule will be balanced. Is that clear to everybody? Yes. Let's take an activity right now. Yes. Shall we be in your group and try the activity on the board? A uniform meter rule XY is 100 centimeters. You have provided 100 grams of mass is attached at each end. 10 centimeters from X and 15 centimeters from Y. Determine the balance points. Yes, start work. Balance it. Yes, I like your work. Now write down the balance points. Write the balance points. Yes. Balance points. Yes, what are your balance points? Yes. 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 Good. Any other? So on average, our balance point is averaging 48 centimeters. So the understanding here is that the 48 itself has the center when these two objects are balanced. That is the center of gravity of this rule, where the resultant force, the total force acting on this acts at this point. Is that correct, everybody? Now, thank you so much. Let's solve another question. Shall we try this? Take your exercise book. Let's try this question. Number 2. Now, number 2. What is the value of x? Who has one answer? We know that clockwise movement is what anti-clockwise movement. So the value at the clockwise movement balance the value at the what? Anti-clockwise movement. So what is the value of x? The distance here, the distance here, x. Anybody? So this one you go home, you go and do it, and tomorrow when we come to class, you give me your answer. Yes, anybody? Any group who has finished the value of x there? Yes. 10. Let me speak. 100. No, let's. Let's assuming 50 newtons, the same mass is attacked. What's the value of x? Yes. 30 centimeters. Do you all get 30 centimeters? Yes. Do you get 10 centimeters?
Yes.
Okay, copy this for your assignment. We come to you. Next time, we solve it to give you the answer. Okay. Thank you so much. End of the class. Thank you.